So this is the presentation, SmartDB and edition-based redefinition, the perfect marriage. And really there's one point which is very simple, but I have to do a fair bit of legwork before the stage is set for me to make the point. And basically, I'm going to do a brief revision, whatever detail I think is appropriate to make the rest of the thing clear. And then I'm going to remind us all of one critical property of this whole SmartDB thinking that is critical for the idea of today's talk. Just in case the brief overviews are too brief, I'll remind you very briefly where the stuff is on the internet. And then having got through this groundwork, here comes the climax. And if I can manage my time, I'll try to illustrate the point with a code demo. So, and obviously I'll conclude by saying it's all wonderful. So here we go. Google for me. I'm sure Googling for tone would be just as good, but you get quickly to the EBR and PL SQL blog. Sadly, at the moment, it's lacking content on EBR. I keep on meaning to fix that. And if you go into that and look around, you'll find a post. It's also my pinned tweet announcing this movie about this whole thinking. I chose the title, Why Use PL SQL there. And you get very rapidly to the YouTube playlist of all the things that back up everything Tone and I have been talking about in this whole series. And correspondingly, if you do my name in EBR, it doesn't take you long to get to some videos, and you see that they're on YouTube. And if you go over to YouTube and type the title that you noticed coming up, you'll get a 8-part series. It's a whole 6.5 hours, but some people have watched it and they didn't die. And it's the full story of EBR, most recently done in a live presentation in the Netherlands. Right, there's your background. Now comes the brief overview of EBR. And you might be surprised by how I approach this, because you won't see any code. You'll only hear me talking. I'll make points that I never hear anyone else who talks about EBR at conferences or talks to me even make. And I think these points are critical. They're the kind of conceptual underpinning of everything. So here goes. First of all, I'm going to make it crystal clear that you all on the conference call here will be able to tell somebody else what EBR is. I'm assuming that you've got some idea yourself, so what I tell you here won't be new to you, but this is the kind of tersest elevator style account of it all that I can think of. What does EBR do for you? EBR lets you make arbitrary changes to the set of artifacts that implement your application's database of record without interrupting its availability. That seems to be a lot of words. Why don't I just say it lets you upgrade your application with zero downtime? It's because the word application means so many different things to so many different people. But in this talk today, we have to mean the whole shooting match across the whole stack. That's the application. And the application has a Oracle RDBMS at its back implementing the database of record. And it's got all sorts of stuff in it, not just tables, not just the things that you can see in DBA objects even, but constraints, for example, and in the general case, application-owned tables who contain rows whose data determines the behavior of the application. That's why I'm using this flash word, artifacts. Next point. Why have we got it? We've got it because it was asked for. Why was it asked for? It was asked for because there was a need, and it was Oracle eBusiness Suite who had the need. So this apparatus was commissioned by Oracle eBusiness Suite. And by the way, it's now been generally available forever, almost a decade. So by the standards of what people talk about these days, it's quite ancient, which means, of course, it's trustworthy, as I'll stress in a moment. So eBusiness Suite, they've got a particular version. It's called 12.2, confusingly. That came out about 5 years ago, and it uses EBR. And that means that hundreds of famous name customers regularly enjoy its benefits. So I hope you can see where I'm going with this. I'm establishing the case that EBR works. And other famous names that you'll have heard of, Salesforce, for example, American Express, MoneyGram, MoveIt, all these people, Avaloq. You can look them up on the internet if you wonder who they are. Of course, you know who Salesforce and American Express are, MoneyGram doubtless. The point here is that it's not so difficult to adopt that other people can't do it, and These other people did it largely without even me knowing until they were pretty advanced in it and wanted to ask me microscopic detailed questions. So this means it's not frightening. And then, the final point then here is that we can conclude from all this lot that EBR is functionally complete. It's no more likely to suffer from bugs than any other subsystem of Oracle database, and it's got no noticeable negative impact on performance. You might think I'm being very defensive in saying that, but I'm a technical guy, not a marketer, and I just like to say things as they are. All systems have got bugs. Oracle database has got bugs. It would be silly to say bug-free. We're talking about bug probability, and when people use words like stable or robust or mature, they're roughly implying the likelihood of hitting bugs, both known bugs that haven't yet been fixed and hitherto undisclosed bugs. And I'm saying about EBR that it shares the same robustness, stability, and general reliability, therefore, maturity, whatever word you like to use, as does, for example, PL SQL and SQL itself. Right then. So this point is key, and I hope you can all rehearse it and use it in the elevator whenever you get a chance. Now then, this is moving to the essential underpinning of today's talk. I have to distinguish between patching and upgrading. Often people blur, or I should say use the terms interchangeably without making any real distinction, and it can be a bit confusing. Patching is the special case, and what it means really is making a change within the whole application, wherever you need to do it in the stack, sometimes one place, sometimes several places, with the deliberate intention of making what's already installed and running what you thought it already was before you discovered some bugs. They might be behavior bugs, they might be performance bugs, but the intention is, of course, never to have them. You thought you didn't have them. Now the thing has been in use, you discover you have got them, and now you do some patching to give yourself what you thought you had before you had this rude awakening. And the critical point there is, of course, there's no semantic change involved. The end users who would go from screen to screen to screen in the middle of a session ought to be able to go from unpatched to patched. In fact, they can go from unpatched to patched without detecting any difference, except if they were measuring the frequency of occurrence of a certain bug, they would see it no longer occurs. And if they noticed that some screen was, punishingly slow, they would suddenly notice that it was quick as you please. So that's patching. And it has huge significance when we are in this SmartDB regime, as we will stress again later. I'll return to that point. Now, upgrading, this is the general case, and it means that you make a change very much on purpose to take your whole application from VN to VN+1 with the deliberate intention of letting all the users see it differently, see new functionality, new fields on screens, new flows from screen to screen, that kind of thing. And in the nature of it, therefore, it's going to be somewhat shocking if you went from version N to version N+1 in mid-session. That's just not allowed as a statement of requirement. So when we consider the general case and we consider this semantic dimension, then we realize that upgrading is possible only if you let people who are using version N stay there until they're good and ready to leave, while once you've prepared version N+1, presumably in secret, then you can flip not individual sessions, but flip the whole thinking about it so that new sessions who want to start in the new version, while people who are still using the old stay in that until they drain away. And that's why we come to talk about hot rollover. More on that in a second. So then we can now work out what properties any solution to this zero downtime application upgrade problem must meet. And there are some functional goals and there are some non-functional goals. And when I say application upgrade, I'm thinking principally on the few slides that follow about the Oracle RDBMS at the back of it, but then we will go on to see how the whole thing flows through the whole stack, and that's critical for what follows at the end. So then there's a kind of immovable object, irresistible force discussion going on here. Somehow or other, whatever technology is invented to meet this problem it's got to have the following effects. Clearly, you want to change what's in use, but you can't change what's in use. That's the whole irresistible force. You want to change it, the immovable object. You can't change what's in use. The only way you can manage it is to create a secret clone of your version n database, and it will become version n+1. Because having cloned it, you make arbitrary changes to the version n+1 without any of this, of course, showing up in the environment where people are using the live system, namely the version n. I hope that's clear. It's just, really playing with words. You tell me you want this, well, you're telling me you want that, aren't you, if you think about it? And of course, there's data involved. The clone was a instantaneous snapshot in the way we're used to when we talk about Oracle and backup and HA and instantiating data guard sites and all that stuff. That was what VN started off as, n+1 started off as an instantaneous snapshot of VN at some moment, but now we've done all the changing, we've got to catch it up again. That's another requirement, and keep it constantly in sync after it's caught it up. And of course, there's more to it than that, because see this word here, refactoring, that's the word we normally use when some physical way of representing data, I mean by that the table design for certain data facts is changed. And an obvious example of that is where you go from a table that has attribute name, attribute value, you realize that was a mistake, and you go to a wider table that has individual columns for each individual attribute. That's an example of refactoring. It's a kind of thing that'll happen in downtime upgrade, and therefore it has to be accommodated in zero downtime upgrade, all in the context of the synchronization. And the final thing you realize now is that not only do you have to keep these things in sync in the forward direction, you have to do it in the reverse direction. In other words, you have to keep the VN in sync with the VN+1 when the VN+1 is open for use, because how else will you be, when some people in a multi-user situation are looking at the data through the old eyes and others are looking through the new, how else will you create the impression that they're all looking at the same stuff? Obviously, you need synchronization in both directions. Not only that, but finally, all these business and data rules we talk about all the time, which are trivially illustrated by a unique constraint, that stuff has got to work in a transactional fashion. In other words, the total set of data, considering these two secret databases, must, in each of them, never give the impression that data rules are broken. There mustn't be any sort of delayed realization that something's gone wrong. All right, then. So this implies then that we'll naturally think of some non-functional goals, because you could achieve all this, everything I said, semantically correctly by going through all the dance that you have to do to create a HA standby. In other words, you instantiate a standby using the well-known techniques, a physical standby, and then just as is done in this transient logical standby technique for major database upgrades, you stop the tracking and then you do whatever you want in the nominal standby, get it right, and then you start the tracking again. But while the tracking was initially physical, because blocks are blocks and it all works, now, because you've done the Oracle database upgrade, you change some structures and you have to use instead logical replication, not physical, but logical. Now we just extend that one step further. We could do that by the well-known technique that, for example, Golden Gate offers, where you can intervene in the SQL that's been computed up by mining the redo and put in some transformations, and that's what you would have to do to handle this refactoring case. But you can see it's all doable. Of course, it would be quite an effort. It would take a long time. And people would consider that to be much too heavyweight. And so we now see that we have a non-functional goal, which, to put it in a very sort of strange way, is this, that when you create the clone, it mustn't need any extra hardware, it mustn't take any extra space, and it must be instantaneous. Now, if you think that's like asking for a perpetual motion machine, all you've got to do is think of some classic some variation on the classic copy on write or whatever you like to call it, deferred instantiation, thin copy, that kind of thinking that we're so used to already in various regimes, particularly, for example, file systems that work like that. So that's part of it. Now, what about this bidirectional transactional synchronization? Well, that's easy. You just put a trigger on every table, both sides, and you have a database link from one to the other and the other to the one. And the trigger in the ordinary case just replicates what happens in the one table into the other. But in the special cases where you've done some refactoring, the trigger has logic to do the refactoring. You can see that's all doable, semantically correct, but you can also see that it would be totally unacceptable because of the performance effects that would have on the running app. So our other thing is exactly that. Whatever we do to meet this goal, it's got to have no noticeable effect on the performance experience of the online users. So all this really leads to one thing, that however the solution is conceived, it must work its magic by making one single database seem to connecting clients as if it's two separate databases. And of course, EBR is exactly this, okay? So now we know EBR magically does what's necessary to meet the non-functional and the functional goals. And it's been in use by thousands of users over the past 5 or so years, well, hundreds, if not thousands. And it's all mature and all the other things I said. And of course, I haven't explained how it works. And in one sense, I ought to, but I don't need to go on to make the main point of today's talk. All I have to do is emphasize this red thing here. One database can be made to appear to the outside world like two, where all those requirements are met, and the connecting clients don't even know if it's all in one database or if it's in two separate databases. I don't want to leave you in total suspense about how it works if you've never heard any of this. On the other hand, some of you will have heard it, and it'll be a bit dull if I go through it in too much detail. So what I'm going to do, first of all, before I get that far, I will tell you some more later. But first of all, what I want to do is not neglect the fact that we have to consider the whole thing across the stack. So let's go through really what is just logically implied, what you have to do by the problem statement. So this is a typical application where, of course, you've got the database at the back end, and you've got inevitably something these days in the middle tier. At the very least, as we like it in the SmartDB thinking, it will be painting the UI and sending top-level database calls to our famous PL SQL hard shell API. Perhaps another variant of it would be that it's no more than a sort of protocol translator where REST over HTTP comes in, or I should really say remote procedure call over HTTP comes in and Oracle Net goes out, but there's still a connection pooling stuff going on in that. And in that case, there'll be intelligence in the browser, which we see coming along there. Here's the browser, who has equivalent functionality to what in previous years we were used to seeing implemented in here. But that distinction really doesn't matter for the point I'm making now. So the first session comes along. This is, if you like, the cold start, and goes the URL that has been published to the outside world is directed to this component here, which I've called the traffic director. You'll see why in a moment. You're used to such a component because you're used to going to, for example, your banking app out there on the internet, and the first thing you have to do is satisfy a challenge. Who are you? What's your password? Having satisfied it, you don't have to keep on satisfying it. So there's some component who looks after that and then marks you in some way as now who you are and that you're authorized. And then that is carried forward for the rest of your session. And I expect you all know that that is conveniently done by using a cookie that goes up and down with all the requests. So here we are now, and the traffic director did one extra step, not just the basic authentication, but it knew from its little register which version of the application was the currently preferred one. In this diagram, there is only one, so it was a kind of no-brainer choice, but even so, it was a choice. And now thereafter, all the URLs done by the session go to the version of the application that they went to at the start. In other words, the end user session is affinitized to a particular version of the middle tier stuff. Right then, and the middle tier stuff, of course, just by virtue of its configuration, connects to the database. So here we go on, traffic builds up, and this is the magic moment. Time for using EBR in the middle, in the database, to do the full-on semantic upgrade that we've been talking about. Bang, there it's done. I'm not explaining at the moment how you do it. I've just asked you to trust me that it's doable by all that kind of empirical evidence that I presented at the beginning. Now, we can see here that it's one database looking like two, and that brings these other properties that we were insistent on getting. But the outside world people don't really care about that. All they need to do is know what information they need to put in some configuration file so that they can connect to the right database. The gray middle tier code is connecting to the gray part of the database. And clearly we're going to need new middle tier code, at least when this is doing the UI. And that's the case we have to consider because some schemes still use that approach. So this is going to have to be rewritten because the database API will have changed and the UI generation will need to change in sympathy. So clearly we need these two side by side, and this new one will be configured so that its connections here in the pool and correspondingly its foregrounds are using the new part of the database. Not to be mysterious, of course, we use the word edition for these two secret spaces in the one and only one database. Now, at this moment, we can switch the switch in the traffic director so that a new session that comes along is directed, there we are, to the new version of the middle tier code. That's how the application version to end user session affinity is done. And the affinity between middle tier code and the database is just permanent by virtue of the configuration data. The gray starts off using the gray and will use the gray for the rest of its lifetime. And so does the pink start off using the pink and will use the pink for the rest of its lifetime too. And there are various ways of getting this to come out right. The way we're used to, or at least the way that's simplest to explain, is the service, which you inevitably use when you connect to a database, or at least so you should, has a property called the initial session edition. So just by defining that statically in the service and by telling the gray guys to use one service and the pink guys to use another service, job done. There are other ways. It's possible to detect in the database, in a logon trigger, some property of the outside world guy, like a client ID or something like that, IP address, whatever is convenient, and then flip yourself into the right edition in that trigger. It's also possible to set some edition property in the, as an environment variable in the environment of the code up here. But you see what I mean. And now this is the famous hot rollover, where the two worlds are in concurrent use in the database and all the synchronization that we need is going on. And now it all comes to an end. And here we are close to the end, where we realize at this transition point here that we're never ever again going to need that old middle tier code. We take it away. We're never ever going to need the old part of the database. We take it away and normal life is regained. Now, the point of going through this animation in the context of today's talk is that while that is essential in the general case of upgrade, it would seem to be ludicrously cumbersome in the case that the whole result of what you did in the database presented the same identical API to the outside world, and you were putting down in the pink what turned out to be identical to what was there in the gray, just to get the hot rollover to work. And so we will see later on then that the essence of the point of today's talk is to avoid that cumbersome stuff when you don't need it. In other words, when you're doing patching, not upgrading. So I hope that's all clear. Now, not to leave you totally in suspense, but not to dwell on this one, I'm just going to step through pictures and use the words without much explanation to say how EBR works. Here's a classic illustration where we have the natural visualization of the HR employees table with the phones in this kind of slightly asymmetrical format, and we want to just rationalize it all into the way you're used to seeing it on your cell phone these days. In other words, we want to change the structure of the representation without changing its semantic content, what I've referred to as refactoring. And clearly, since we're advocates of SmartDB, there will be PL SQL code in the database who's sensitive to the way the data is represented physically. So that'll have to be changed too. And in this case, the two, where it used to be one, fields will have to go out to the outside world, to the UI. So then, here we go. This is how it works. This is our starting point. I said we need some notion of sparse copy, and you'll kind of see how it goes as we go through. Here is the magic of the addition, and strangely or interestingly, but very much by design, PL SQL views synonyms there in additions. They're in these secret spaces, but tables, regular tables, just float there in, if you like, in a vacuum outside of the wonderful world of additions. And this is very much by design because that's where the data is. And if you can avoid synchronization when you don't need it by having the data just uniquely represented, that's a big win. So we'll see how that works now when we go through. Create a new edition has the semantic effect of simply copying all the PL SQL, all the synonyms, all the views, all that, those things into the new edition. Actually, the copy is deferred, but the illusion, the semantic effect, is as if you had done the copy. And now you're getting a sense of how we're doing this instantaneously. That step clearly can be instantaneous because all we're doing is some kind of pointer stuff like with Linux links. So then now we have to think about the table. We have to have extra columns on it. I won't explain all the detail of that. I'll just promise you that ever since 11.1, it's been possible to add columns to a table while there's never a moment that the table from other sessions doesn't have uncommitted DML in it. This is kind of rocket science, and I can demonstrate it, but there's no time today. We'll just take it for granted now, if you didn't know it, that this has been working since 11.1. And moreover, this thing here now, we'll see what I mean by this. It's a view, a special kind of view that we call an additioning view, and it's projecting the table, which is out there in no man's land, into that addition the way we want it to appear. In other words, with the old phone number column. And because of fine-grained dependency tracking, this will remain valid when we add these columns that the select statement that defines this never mentioned. Now, having done that, we can turn our attention to the new world, and we realize, of course, we don't want the table to look as it used to look. We want it to look as if it's got these two columns and not that one. Well, that's easy. We just redefine it with a different select statement, and correspondingly now we update the code in there. And this is the moment where these things become physical, whereas before they were just ethereal. They were just inherited. Now they're actual, as we say. And in the general case, of course, you've got tons of other stuff out here that's not being touched in the present exercise, and that will remain down in the old green edition, while only the stuff that you touched is up there in the new edition. Now we have to consider the synchronization. We use a special kind of trigger that's part of the apparatus called the forward cross-edition trigger, and you can see by the arrows how it works. And we can just, if you like, tweak every row to fire the trigger, so we've populated the data as we want it to be. There's a story around that too, but I won't go into the detail. I'm sure you can get the general sense of it there. And of course, we need to do the backwards job. Well, that's easy enough too. We create a special kind of trigger. It's called the reverse cross-edition trigger. The thing about these two is they know when to fire. This one, the forward one, fires when sessions using the old edition do stuff and inevitably are talking about the phone column in its own way, old way. And this one, the reverse, fires when sessions are using the new edition and make changes to the phone idea by touching values in one or both of the new columns. So you can see all you have to do is write the right code in the body of these and it'll all work out magically. So this is our famous hot rollover where the two are in concurrent use. Eventually it all drains away and we realize we've got here, and this diagram, by being gray at the bottom, just means we've decided the moment has come that we don't need that any longer. And the simple command drop edition will, from 12.2 onwards, do all the magic without troubling you about the detail. And the things that we redefined and are no longer visible up there just vanish. And in the general case, of course, there's other stuff that you didn't touch, and that old edition stays there physically, but semantically vanished so that you can never use it again. And background process can do whatever necessary. In the case that you actually end up with the thing totally empty, then that goes away too. And your final step is to mark that column as unused. And if you care to do an online table move, then at least the space taken by the old values will be replaced by null. And you will have got to a pretty close to ideal state. If you look under the covers, they've still got a hidden column there for the unused thing. But unless you've gone mad in a way that Tone explained you shouldn't go mad in one of his recent talks about database design, then you won't have as many columns as take you close to the column limit for a table. I think that if you are troubled by the number of columns you can have in a table, you've gone wrong already, but let's not dwell on that today. So that's EBR. Now, moving on to SmartDB, I think I can get this done in the hour. Let's see. First of all, you've seen this so many times that I expect you're fed up with it now, and I'll just step through it. But when I do this first step, I should make a point that was not at all apparent to me, but Tone pointed it out to me. It looks like when I do this to this, I'm implying in some way, data is a schema, code is a schema, that we have schemas within schemas. I didn't mean that at all. And sorry if it's confusing. I realize now I should redraw this picture just as a kind of stack or a pool of schemas with various lines between them. But what this visual metaphor is meant to mean is only that the guys who can manipulate the data are in the pink, and by virtue of them and only them being what's going to manipulate the data, then the data is, if you like, enclosed within the shell of the code. That was what the metaphor was supposed to show, but it seems to be confusing. And so it goes on here, that the exposure of the API in these guys, by pointing to the appropriate bits in these guys, again, is meant to be a sort of enclosure idea, but of course, schemas don't work in this surrounding fashion. So, not to dwell on that because we've heard that story a million times now, we get to the end there, all the C back rolls, everything, and here we are with the whole thing complete. This detail I talked about earlier on, error handling and the way you connect when the time comes for patching. But I'll just re-emphasize that thinking clearly about this way you get the privileges you need to do patching while other sessions who are still in use don't have those privileges, it's not anything you need to think of when you take downtime for patching, but it is something you need to think of when you do EBR. That's why I was so keen on, let's say, establishing some principles of practice in this area of the discussion when we did the vanilla SmartDB presentation. So then, this is the only bit of that whole shooting match that we really need to grasp for today's talk, the critical property, and it's this. It's exactly that. The only way into the database, whoops, sorry, I hit the button, but the only way into the database, whether it's fashionably modernly through RPC over HTTP and a protocol conversion in the ORDS and into a JSON in, JSON out shim, or whether it's the old-fashioned hairy-chested OCI coming from some daemon going straight on the PL SQL, that's not the point. The point is that anything that is done by the outside world is done exclusively by calling PL SQL subprograms. And we established, I'm sure until you're fed up of hearing it, that you can, if that's your intention, you can achieve it, enforce it trivially just by making sure that the schemas where you, or the schema in this diagram, but the schema family in general, where you connect, in other words, the user owning that schema whose credentials you give to the outside world, you just ensure it's empty, quite simply, and you ensure that the only privileges it has is execute on your PL SQL. So that's a trivial way of insisting on you getting what you want. Now, there's some controversy here. There are people who think that you should have views as part of this API definition. Well, I'm happy for them. They can do that and they can call it what they want. But if the name SmartDB is to be useful, it means not doing that. It means doing PL SQL encapsulation in the way we've described. Now, I'm not saying that that is going to be appropriate for every single use case on the planet. But what Tone and I are saying is that there's an interestingly large class of use cases where it is appropriate. And when and only when you do this, then you have the opportunity, let's see what I say on the next slide. No, I'd better say it here, to do the magic that's needed in the whole scenario we've set up for today's talk. And it's this: because everything that you do starts with a PL SQL subprogram, one of these guys, you can trivially put in a side effect or side effects if you need them. They should be non-semantic side effects, of course. They shouldn't affect the actual visible behavior of things. But for example, at the start, you could switch on a clock, and at the end, you could switch it off. And at the end, too, you could log out using autonomous transaction, how long you're in there. You've got a trivial way of establishing statistics about the database time, as it's sometimes called, for your essential business functions. You've got what you want at the right level of conceptual granularity. That's one example. And I chose that because that requires you to do something at the start, do all your normal stuff, and something at the end. And I'm making perhaps a little fuss about this because there were people who were suggesting that you could use some cunning scheme in a view so that there was a function involved in its definition and the function got called and you could put the side effect in the function. No, I don't think so, because that would be invoked only once, even if you thought it made sense to have functions with side effects in select, that acted on by select statements. But you couldn't achieve the general functional goal where you need a prelude and a postlude. But for this EBR case, it so happens that you just need to do one thing. And what you need to do is flip yourself. And I'll show you the code in a second, and then I'll demonstrate it. But just a word on flipping. There is, of course, a command alter session set edition. And you can choose to go to whatever edition you have privilege on. But that one you'll soon discover if you go begin execute immediate alter session set edition blah blah end, that will cause an error. It doesn't cause an error because we haven't quite finished doing something that we want to do. It causes an error very much as a consequence of some deep analysis. I won't give you all the detail, but suffice it to say that thou shalt not be allowed to change the edition by alter session set edition during an in-flight top-level call. All you can do is dedicate a top-level call to the purpose. However, there's an alternative, and it's got deferred action, and not surprisingly then, it's implemented in a PL SQL subprogram called DBMS session set edition deferred. And that's what we're going to do here. In our side effect program, we're going to put the same we're going to call the same procedure in each of these API things, and its purpose is to ask the question, am I in the edition I should be in? If yes, do nothing. Or, as a little sort of rider on that question, do I even care about where I'm being told to go? If I'm not told to go anywhere, then clearly I'm going to stay where I am. On the other hand, if I'm supposed to be in edition E17, but I am in E16, now is the time to do this call, set edition deferred, and next time I come in, I'll be in 17. I hope that's clear. Why the null idea? Why, I'm not saying anything at all? Exactly because we have to invent a scheme that not only works for this behind the scenes, throwing everyone over in mid-flight to the new world, but also works for the general case of upgrade. Now, it occurs to me that I may not have hammered home the central point strongly enough, so I'll do it at this moment. This whole hard shell thinking rests, of course, tautologically, on the notion that you've carefully defined a set of PL SQL subprograms to be your API. And there's not going to be that many of them when you compare that with the number of distinct SQL statements, for example, that might be issued, or the number of objects you have altogether that implement your RDBMS backend. And it's very doable and not only doable, but it's essential to think very carefully about this API design. And the API design is the contract between the database and the outside world as it characterizes a particular version of your application. And by virtue of doing all this proper, careful thinking to design the API, it kind of is a circular consequence. It's almost tautological. That API then is not going to be syntactically or semantically affected by bug fixing. It's only going to need to be changed when you do upgrade. It's not changed by patching, it is changed by upgrade, and patching is more frequent than upgrading. So what we're looking for is a way to just flip sessions from within the database as soon as we've prepared the patched world without even bothering to tell the outside world what's going on. And just think what a liberation that is for one's ability quickly to respond to newly discovered bugs. Right then, so now I'll show you the code. It's absolutely brain dead in a sense, but before I do, let me show you the meat of these API subprograms, because there's a little bit more here than I've ever said before, and now is perhaps a good time to say it. There was some fuss in Twitter and various offline discussions about who owns commit. And I'm going to stick to my guns here, and I'm going to say that there's a large and interesting class of use cases where all you want to do is make some changes within the database and either commit or rollback there and then in an ordinary atomic fashion. Obviously, people started going on about distributed transactions and using AEQ in a special way to send emails by client-side code, all sorts of things. Fair enough. There are different use cases out there too, but in this one, you're going to go in there, make changes, commit or roll back, and come out. So I'll show you this one first, actually, the DML one. Insert one row. It's brain dead functionally, but that's not the point. So I've put all the guts of it in a procedure that I've called body, and I've made that pragma autonomous transaction. Why have I done that? Just because it's one of the rules of this whole concept that if you don't either commit or roll back in your own code when the block is executed, well, you'll get a runtime error that does the rollback for you. So it's a simple way to enforce the paradigm. And what is the body actually going to do? It's going to do one extra little thing. It's going to make sure that no one by who knows what method has subverted our scheme. We're the only people doing transactions. There's an easy thing you can measure to see if there's an open transaction or not. I check that, and if there is one, we abort straight away because something somehow went wrong in our implementation of the concept. I'm also going to check in there, by the way, if someone in the outside world, contrary to expectation, has manipulated the world with DBMS flashback sets, whatever it's called, the point in time at which you're doing stuff. Then we do the stuff, and here is the thing. Ensure that the next call starts in the intended run edition. When we talk about this in general, we say that in normal life, there's only one edition you care about. It's the edition you're running in. It's the run edition. When you do an EBR exercise, you create a new edition, which starts off as the patch edition. Eventually, you retire the run edition you started with, and you promote the patch edition to be the new run edition. That's where the vocabulary is used, and it's general. It's better to use that than E47 and E48 most of the time. Now, let's just go back to the one that does a query. Show all rows. Again, there's no interest in the logic. All it's doing is selecting the whole shooting match into a collection and returning it. That's not the point. Don't ask me if that's realistic or not. It just illustrates the point that I'm doing this too in an autonomous transaction. Why am I doing that? Because I'm choosing to set transaction read-only in my own code in this smallish number of subprograms who do queries. And the reason I'm doing that is to enforce the regime that even if I'm going to build my return value by doing several distinct separate queries, therefore at different points of time, I will just automatically produce a read-consistent view of the world. People don't often think of that. They happily do one select and another select and another select and send the whole stuff back to paint one screen as if it's a picture of the world. I think everyone I've seen talking about PL SQL at some conference at one time or other has showed that idiom. But if you think about it, it's just completely faulty unless you do this too. And who's going to who's going to trust the outside world to think about that stuff correctly? But behind our hard shell, we can just own that in a trivial fashion. And if it's in an autonomous transaction, well, we've just got to do the rollback at the end, otherwise we'll get the error and so on. So it's just a nice way of enforcing, again, as it was with the DML, what we want. And the guts is the same: assert no open transaction, do the body, and then make sure we start off where we want to be next time. So then how does that work? Well, I'm going to need a datum, obviously, to say what edition is the preferred one, and it can contain null, meaning I don't care, I'm going to use the service or whatever to determine the initial session edition, or it can have a real value in it. And obviously I'm going to use a one column, one row table for that datum. I can even enforce the one rowness with a little trigger. Why not? I may as well be correct. And I'm just getting the value, the datum in question, with an obvious select, and I'm returning it. How easy is that? And obviously, I'm going to make it result cached. Why would I not do that? Because I'm going to consume it in PL SQL, and I just want it to be instantaneous in the typical case. Don't forget, this is going on with every single call, and it's only now and then, maybe every 2 or 3 days, that you once need to flip into the new edition, and then it's back to the steady state again, where the result cache thing really helps you. So what does the consumption of this look like? It's, again, not very hard. This is the procedure to ensure you start in the right place next time. And I'm just, because I like this style of programming, almost, but not quite, functional programming, I'm defining the session edition name. That's where I happen to be sitting as a constant, not null, because I like to do that. And I'm getting it off syscontext. You can guess something like this exists. And then I'm getting where I ought to be by, again, populating a constant, not null, of course. And I seem to have left out the words not null there. Dear me, mea culpa. And I'm getting by running that result cached function. And then obviously there are 3 cases. If the datum is null, I'm certainly not going to do anything. If I am where I am already, I'm certainly not going to do anything. Only if I am not where I am, or sorry, if I'm not where I should be, do I do something. And this is the thing I talked about. DBMS session set edition deferred. Notice how anally I like to qualify these things with sys all the time. And this is the only, what happened there? Cancel. This is the only thing I didn't give you a clue about up front. You can guess that if you've got packages in an old edition and packages in a new edition, then when you instantiate them, even if they happen to be identical in definition in the 2 editions, their state is instantiated in both editions distinctly and separately. Therefore, if I'm leaving behind an old edition, I have to just wipe out all that stuff so that I am, doing my good housekeeping. And it's not hard to do that. This is the call to do it. And once again, you don't have to think about performance here, because it's just going to be called once in a blue moon. And if you weren't doing this, you'd be taking downtime. Well, how does that affect your performance? So I don't think you'd notice it, but don't even start to ask what effect it has on performance, because you do it so rarely. And anyway, you have to do it. Right then. So now demo time. I'm going to go for broke here. I'm going to just restore my whole PDB in which I'm operating from my unplugged gold master. It doesn't happen to be very interesting. It's just got a few little bits and pieces I like to have there. But there we go. It's 8. You can see from the name, if you could read the small print, that it's a 18CXE thing running on my laptop. And it takes ages when you're staring at it. It's about 10 seconds. There we are, to give me a complete fresh start. That's done. Now I'm going to install all the kit that I need for the demo. And here we go. But actually before that, sorry, almost missed it. I'm just going to go over to the server environment and come out of this, clear the screen, and see what services I've got. At the moment, I've got this mysterious guy that you always get, and I've got the service for the CDB, of course, and I've got the service for my PDB. This is the service you're not supposed to use. This is the default service. Not surprisingly, I've got only that because I've only just restored the PDB from scratch. So then, first thing I'm going to do now is this reset guy, which will just get me to the state of the pre-upgrade app that I'm modeling here. I hardly need to say any detail. It's roughly like the phone number app. That's not the point now. We've talked about that. And to make it realistic, I've just arranged that the only edition that survives is E7. Okay? It's easy to do that in 12.2 and later. And if I run it again, I'm still going to wipe everything out, start again, and I'm back at E7. Right then. And by the way, now we've got our whole app installed. Now, what I'm going to do is go over here again. For various reasons that will soon come clear, I'm going to see what trace files I've got, and I'm going to just get rid of the whole lot. RM star. Right, they're gone. Double check. Nothing left. And now I'm going to see what services I've got. And now I've got a red service as well. So the idea will be I'll be toggling between red and blue at one, on the odd number of EBR exercises. Red is the leading one, the run one. In the gaps, blue is as you'll see in a minute, the leading one. Let's just test that by going into SQL Plus, no log, and by just running my login script to make it easier to see what's going on. Then I'm going to, where's it gone? Here, connect. The user's called U1, imaginatively. The password is P. The node in question where the listener is called X. The service is red. There I am, and I'm connected. And if I just check using one of my little helpers where I am, there we are. I'm in 18, and that's in, as we saw before, edition E7, and the user is U1. Right then, good. Now we will go over to the red session and exercise the app. And here it is. I put a little pause at this stage because I wanted to show you this is, if you like, mimicking the browser who's calling the PL SQL API. I'm just getting the value from my show all rows and putting it in a constant of the right data type. And then I'm just going to step through its elements and paint them out on the screen. Obviously, that's not very exciting. And there's not much in my table. You can guess there's a table, and I'm going to widen one of the columns, in fact, but it's got a blue fish and a black dog in it. That's all there is. And now the interesting thing to do is to go back here and see what happened by seeing what trace files we've got. We've got a few. Wait a minute. These things are from backgrounds. This is the one that matters to me, my foreground. And if I just tail it, you'll see that the message coming from an observer that I didn't show you in my go where I should be function is saying that actually I wasn't told to do anything, so I'm staying put in E7. Why am I doing this? I'm using a well-known but unofficially unsupported API who just puts messages into the trace file. It's because I can't use DBMS output for this, because when I blow away the state, the messages I want to see would be blown away as well. I perhaps should have used a table and selected out the table to get the message afterwards, but that seemed to me to be more clutter, so I just did it this way. I hope that doesn't confuse you. Now then, let's just repeat this. Obviously, we've seen the same answers there, but the key point is that, once again, he said, am I in the right place? Oh, I am in the right place, so I'm not going to do anything. Okay? Right then, now what we're going to do is just do the EBR exercise. We're going to prepare the patch edition. Now, if I had twice the time, I could tell you the detail of all this lot, but I'm just doing stuff. And basically, I started off with this. I had a table with P, C, and sorry, I didn't scroll back enough. I started off with a table who's got a primary key and a column C in it. That's what holds the blue fish and the black dog. And I've got an additioning view on the top of it. And obviously there'll be an index and some constraints and stuff. And I've got some objects here. I didn't clean up well enough from some other experiment I was doing, but never mind that. I've just got some procedures and so on lying around. And they're all in E7. Right, and then I do my stuff and I come out the other end and I look again. And now we've got in the table a C wide because I'm widening a column. The editioning view is now projecting that wide column as 50. And I've got some indexes appropriately named for what I just did. And now I've got stuff spread among 2 editions, okay? And this guy here, who's got no consequence for the present exercise, remains firmly in E7, while this guy, show all rows, who I had to change, and for that matter, insert 1 row, package and body, they're in both editions, okay? Because there's the old definition and the new edition. And here's my cross-edition triggers, the forward and reverse. I hope that makes enough sense to give you a rough idea of what's going on. So now I have to see who's where. And at the moment, I'm querying up $session. And obviously, there's 1 session in the new edition. That's me doing the EBR exercise. But there's 2 in the old edition. Actually, one of them is this. Let's go back there. Okay, 1 in each, right? The red one is in E7, and the patching guy is in E8, as we expect. Now I'm just going to, back in the red edition, I'm just going to do this block that I've got there. Let's just see what it is. I'm going to do it 1 more time. Now, it ought to print out the answer, oughtn't it? Nothing is seen on the screen. Let's just go back and look over here. And it said switching to E8. But of course, it blew away the package state, and I was using DBMS output to show the stuff, so we didn't see anything. But let's look at the services now. You'll see that we've got now a new service called blue and one called red. So let's try them out. Obviously, you can understand I can create them programmatically, and I did that. So there I am in SQL+. I'm just going to run my little login thing. Now I'm going to connect as the red. Where am I now? Now I've redefined red because red is the one that I'm using for the leading edition. So it's pointing now at the new edition, E8. Now if I connect using the blue, then we'll see, oh, sorry. Little glitch there. We're in E7. Okay, so that's how the service is used to choose the edition you want. We're almost at the end now. All I've got to do is promote the patch edition to the new run, which is the bit that we saw at the end of the animation. Just clean up the GAC from before, really. That's basically what I'm doing. And come on. What's going on? Have I managed to stall it somehow by being in too much of a hurry? I think I am, but it's now 11:01. So trust me, you don't need to see the last bit here. You've seen all the essence of it. Let's just see if we can show who's in what session now. I should have done that before. We've got the one guy over here. Sorry, demo technique failing me. Who's still in E7. But over in the real world, where I'm interested in stuff, we've got all of us now in the new world.